Hi, Miss Lim, and hi, everyone. This is our assignment video, and our topic is Chapter 5 CPU scheduling. So now I'm showing my laptop with you guys, and I hope everything is clear. Okay, so let's get started our exercise here. So this table is provide the information such as process, burst time, arrival time, and priority. And we can see here got seven process. Is P1 to P7, and each process has its own burst time, arrival time, and priority. So now I'm going to show you how to calculate and decide which the process execute by the CPU first. So now here is round robin quantum 5. So first of all, we have to put 0 over here. So we have to see which process the arrival time is 0. So now we see here is P1. So we over here we write down P1, and the burst time, okay, BT stand for burst time. Okay, so the burst time is 6. So over here we write down 6. Okay, so in here also we write, okay, is P1 execute by the CPU. So in here, so what the meaning is quantum 5, that means is only can the maximum is execute for millisecond is 5. So in here we write down 5. So after 5, arrive time before 5. Okay, so right here we can see that after process 1, okay, arrive time is 0. In here we also have arrive time for P5 is 1, and for P6 is 2, for P7 is 3, and P3 is 4, 5. So over here we have to list down the days process follow the arrive time. So right here, so after 0 is 1, so is P5, and the arrive time is 4. Okay, so here we write down P5, and the arrive time is the burst time is 4. Sorry. So after P5, okay, after arrive time 1 is P6, because the arrive time for P6 is 2. So right here we write down P6, and the burst time for P6 is 8. So let's continue for P7, because the arrive time is 3. So here we write down P7. The burst time for P7 is 10. After the arrive time 3 is 4, right? 4 and 5. So P3 and P4. Okay, process 3 and process 4. So process 3, the burst time is 4, and the process 4, the burst time is 5. So it's 4, 5. So 4 and 5. So we have to write down, okay, process 1 again, because for process 1, the burst time is 6, but CPU only execute process 1 for 5 milliseconds. So 6 minus 5, still 1 left. So right here, we write down 1 for process 1. Okay, we have to highlight that. That means we already execute for this process already. Okay, let's continue. Okay, so right here, okay, after P1 is P5. So right here we write down P5, and can CPU execute for process 5 for 5 milliseconds? Okay, the answer is no, because for P5 the burst time for P5 only 4. 4 milliseconds is less than 5 milliseconds. So right here CPU only can execute process 5 for 4 milliseconds. So 5 plus 4 equal to 9. So right here we write down 9, and yes, the process 5 has been done, have finished already. Okay, so right here we highlight that. That's mean already execute. So right here we no need to list down P5 anymore, because P5 already done. So okay, after 5, we still got one. Right time is 6. They haven't list down. Okay, so right here we have to list P2. Right here is P2, and the burst time for P2 is 8. So after P5, okay, is we continue. So after P5 is P6. So right here we write down P6, and the burst time for P6 is 8. Okay, 8 is definitely bigger than 5. So right here we can 9 plus 5 is equal to 14. So here we highlight, okay. So right here we have to write down P6 again, because CPU only execute process 6 for 5 milliseconds, but the burst time for P6 is 8. So 8 minus 5 still, okay, 3 left. So here we write down 3. So we continue. So here is P7, and the burst time is 10. So CPU can execute for 5 milliseconds. So here is 19. So right here we also highlight, and P7, okay, 10 minus 5, so 5 left. So we move to P3. Okay, right here is P3. And the burst time is 4. So it's the same lah. CPU cannot execute process 3 for 5 milliseconds. Okay, because 4 is less than 5. So right here we only can execute, okay, 19 plus 4. So it's 23. So 23 right here. Okay, and here we highlight That's mean already done, already execute. Okay, so we don't need to list out anymore for P3 because P3 is already done. Okay, has done already. No more, no more burst time can execute by the CPU anymore. Okay, so we move to P4 and P4 right here. Okay, burst time for P4 is 5. 5 is equal to 5. Okay, equal to 5. Okay, right here. So we just follow, we just let CPU execute process 4 for 5 milliseconds. So 33 plus 5 is 38. Is that right? 33 plus 5 is 38. Yes. So right here, we highlight that that's been already done, and we continue to P1. So P1, okay, we only can let CPU execute process 1 for 1 millisecond. So 38 become 39. And finally, process 1 has been done. Okay, so we write down P2 over here. And P2, the burst time for P2 is 8. So we only can execute for 5 milliseconds. So 39 plus 5 is 24. Okay, we highlight that. And we have to list down P2 again because 8 minus 5 still 3 left. So right here, also we continue for P6. So right here, we write down P6 here, and the burst time, the CPU has to execute for 3 milliseconds for P6, process 6. So, so 34 plus 3, 34 plus 3, 37. Okay, so here is 37. Okay, I hope everyone, I hope it's clear lah. Okay, so here is 37, and process 6 is done already. So we still got process 7 as process 2. So we continue that. Okay, so right here we continue to process 7, and here is 37. And process for process 7, the burst time is 5. So 37 plus 5. So it's equal to 42. So right here we write down 42. And here is clear, is has been done already. So in the end is process 2 and 42 plus 3. So for 42 is equal to 45. So that is the, so we finished already. Sorry. So now we finish all the Gantt chart already for round robin quantum 5. Okay, so we have actually got one tips for checking your answer is correct or not, your Gantt chart lah. So right here is 45. Then we can add all the burst time like this, and 6 plus 8 plus 4 plus 5 plus 4 plus 8 and plus 10 and equal to 45. It must be same lah. It's different. Maybe your Gantt chart is something's wrong. Okay, so here is some tips for drawing the Gantt chart here. Okay, so now we have to calculate for the waiting time. So waiting time for process 1 is, okay, we have to see here. Process 1 execute by the CPU have 2 times. Okay, the first time is over here and the second time is over here. So have 2 times. So we take the right time, we take the here over here, the number over here minus a right time. So it's 0 minus 0 and plus and plus here we take the number over here. Okay, is 28 minus the process 1 over here. The number over here is 5. So it's equal to, okay, 0 plus 0 minus 0 is 0 also, and plus, so waiting time for process 1 is 23. So process 2 we see over the Gantt chart. Process 2 has executed by the CPU for 2 times. Okay, the first time is over here and the second time is over here. So we take the first time. Okay, this is the response time. Okay, I remember already is response time. So we take the 29. We take 29 minus the arrive time for P2. So the arrive time for P2 is 6. So minus 6 and plus over here the response time is 42. So here is 42 minus. So the waiting time for process 2 is 31. Now we look for P3. So P3, okay, so right here P3 is the burst time is 4. So it's only executed by the CPU for 1 times. So the first, okay, the one time other is over here for P3. So the response time is 19. So we write here 19 minus the arrival time. Arrival time for P3 is 4. So 19 minus 4 is equal to, so we move to process 4. And the process 4 is, okay, the response time is 23. And we see the Gantt chart over here has no more than one lah. So the so CPU execute process 4 only 1 times. So we take the response time is 23 minus the response time is no, sorry, arrival time is 5. Right here, process 4, arrival time is 5. Right? So we see P5, the burst time is 4, so we can guess in the Gantt chart CPU only execute for P5 only one times. So we see over here, okay, P1, P5, okay, only have one times. So the response time is 5. P5 response time is 5 minus the arrival time is 1. P4, P5. So it's equal to. So we see, okay, P6 right here, the burst time is 8. So we can guess CPU execute process 6 for 2 times. Okay, so we see over here, okay, we have the first time in over here and the second time over here. Okay, so we take the response time for the first time is 9, second time is 34 minus the P7, the response time for P7, so it's 14. So finally, we have the we move to last. Okay, it's process 7. So process 7, the burst time is 10. So we can guess the CPU execute for process 7 is for 2 times. Okay, so we see over the Gantt chart. So process 7, we have one over here, and we have first over here, and we have second over here. So we take the response time for P7 is 14 minus the arrival time is the arrival time for P7 is 3, so 14 minus 3, and plus the second response time is 37 minus the P25. So right here, okay, we finished the calculation for waiting time P1 until P7. So for advantageous times, we have to add all the waiting time process 1 until process 7 and divide you how many process you got. Okay, so it's 20.428. So we can write here is 20.43. Okay, ms. So right here, we've done all the we done the round robin quantum 5 already, done this exercise already. So okay. So I think everything is clear for you guys, and thank you guys, and that is all for me.
Hi, Miss Ling, and every student. Okay, my name is Lo Hongzi, and then I'm now going to continue what Jinder ended previously, and I'm going to show you guys how to calculate the preemptive shorter job first. Okay, I hope everything is crystal clear right here. Okay, so I will start now. Okay, so we will look at the table right here, and we'll see this is a process, this is the burst time, this is the arrival time, and this is the priority. So how do you calculate the shorter job first? Okay, first thing we need to do is type in 0 right here. Okay, and then which process matches with the 0 right here is process number 1. So right here, you need to write down process number 1. 1 equals to 6. Okay, then there's no other choice, so right here we will write down process number 1. Okay, then let us continue. Okay, so right here, okay, after 0 is of course 1, and then this will copy. Wait, I will highlight for you guys to know the answer for it. Okay, so process number 1 equals to, okay, so right here we need to write down process number 1, but 6 already minus by 1 millisecond. So right here we will write down process number 1 equals to 5. So 1 millisecond, which process matches with 1? Which process match with 1 millisecond? So we will see at the table process number 5 match with 1 millisecond. So right here we write down process number 5 equals to the burst time. So it's 4. So okay, in this case, we got two groups of number. So two processes. Then we will choose one. Okay, of course, we will choose the smallest digit among the burst time. So 4 and 5. Of course, 4 is smaller than 5. So right here we will place process number 4. So I will highlight for you guys. Okay, process. Okay, so 2 milliseconds. Okay, so which process, as usual, which process matches with the arrival time? 2. Okay, process number 6 right here. Okay, so we will write down P1 equals to 5, and then P5 equals to 3, because 4 minus 1 is 3. Okay, then we got one more process. Okay, so the process is P6. P6 equals to 8. Okay, so right here, as usual, P5 is the shortest. Okay, P5 is the shortest first time. So right here, P5 is the smallest digit among all of them. So we will write down P5. Okay, so let us continue right here. Okay, 3. After 2 is 3. And then we'll write down all of this first. So P1 equals to 5. And then P5 equals to 2, because 3 minus 1 is 2. Okay, and then P6 equals to 8. Okay, so let us see the table right here, which arrival time matches with 3. So it's P7. Okay, so right here, we'll write down P7 equals to 10. Let us see the first time right here, 10. Okay, so as usual, P5 is the smallest digit among all of them. So we will highlight for you guys to see more easily. So we'll write down P5. All right, so on to the next part, number 4. So we will write down all these process first. Let's see from the table, which arrival time is 4. Okay, P3 matches the arrival time. Okay, so we'll write down P3. So P3 3 goes to 4 reverse time, as you can see right here. 4. Alright, goes to 4. Okay, and then right here we will choose the smallest first time. Okay, so it's P5. So we'll write down P5. Okay, so we'll move on to the next part. So right here is number 5. And then okay, so right now P5, for the P5, the job is being executed, it's already done. So we don't need to write down any more process number 5. So we'll just write down start from process number P1, P6, P7, and P3, and we'll find out which process should be written down. And then okay, let's see from the table which process matches with the arrival time. So 5 right here, 5. Okay, P4. Oh, sorry, this is P3. Okay, sorry. Okay, so P4 matches with the arrival time. So right here we'll write down P4 equals to, and then let's see the number first time. So it's 5, as you can see right here. Okay, so right now we will choose the smallest among all of these. So of course it's P3. Okay, so it's P3. Okay, so right now, here we will put in 6. Okay, for you guys to more understand. Actually, no need to go down, it's also can. Okay, so right here 6, we continue. Continue. Okay, below here. Okay, so as usual, we need to write down all of these 6 in the second. So let's see. P2, okay, matches the arrival time. So P2 equals to 8. The last one, P2 equals to 8. Okay, so right here, as usual, we need to choose the smallest digit. So of course it's P3. I'll highlight for you guys. We'll put down P3. Okay, so right here we will write down 7. Okay, and then let us see from the table which arrival time matches with the 7. So as you can see right here, there's no arrival time matches with the 7 because all of the process has been arrived. It's already arrived. Okay, so as you can see right here, all of the process has arrived. So we cannot continue to do like this because you won't calculate the answer. So how should we do it? So as you can see, process number 3 is the smallest first time. So right here we need to do some math. Okay, so 6. Okay, right here 6 plus 3 equals to 9. Okay, so because process number 3 is being executed right now, so 6 plus 3 equals to 9. Okay, so right here, okay, we'll continue to our. I'm sorry. We'll continue our calculate P6, and then right here we don't need to write down P3 already because P3 is already done. So last one is P2. Okay, so right here there is some this. Okay, so as you can see right here, we got some problem. Okay, because we have P1 and P4, both of them have the same burst time. So which process are we going to choose? Let's look at the table and the section priority right here. As you can see, okay, we will choose the process by looking at their priority. So in this case, the smaller digit priority means that it will be chosen for being executed first. Okay, so let's see process number 1, the priority number is 5. So we'll put it 5, okay. And then for process number 4, the priority time is 1. Okay, so right here, we will choose process number 4. Okay, let me, so 3, 2, 1. Okay, so process number 4, we will choose process number 4 because 1 is smaller than 5. Then we look at the priority 1 and 5. We will choose the smallest one. Okay, so right here, we will put in process number 4. Okay, so what should we put back here? Is it's the same thing. Okay, you just plus 9 plus 5 equals to 14. Okay, as simple as that, 14. And then okay, we will type in the same thing. And then this is already done its work. The job is already been done, so we don't need to write down anymore. So right here, of course, P1 will be choose P1. And then right here, we'll type 19 because 14 plus 5 equals to 19. And then right here, continue. Okay, so right here, the same problem. We got two process, the burst time, the number, the digit is the same, 8. So we'll look at the priority. Okay, so P6, the priority time is 3. Okay, 3. And then we'll look at P2. P2 priority time is 4. So we will choose P6. P6. Okay, so 19 plus 8 equals to 27. 27. So right here, okay, let's continue. There's two more process left. P7 equals to 10. And the last one is P2 equals to 8. P2 equals to 8. Okay, so of course, P2 is the smaller digit among both of them. So 27 plus 8 equals to 35. Okay, so we only got the last process, P7 equals to 10. Okay, so of course this will be choose because this is the last one. So the final answer P7, but we have not yet finished. Okay, sorry, I need to type in. So 35 plus 4 plus 10 equals to 45. So as you can see right here, 45. Okay, so all of this you can see right here. Okay, we already got the Gantt chart answer. As you can see, I already highlight for you guys. Okay, I will show you guys how to calculate the waiting time and the average waiting time at the end. Okay, so okay, let's start from the waiting time first. For process number 1, okay, so we'll see through the Gantt chart how many times process 1 has been executed. So you can see right here, this is the first time, okay, first time, and this is the second time. Okay, so 2 times. Okay, so how are we going to calculate? Okay, we will take this first, I mean the left side of the number, and we'll minus the arrival time right here. as you can see. Okay, so let me just type down for you guys to understand. Okay, plus. Okay, right now we will take the left side of the number. So it's 14. Okay, I'll write down first 14 minus. Okay, right now it's not the arrival time already. So right now it's about this. Okay, so 14 minus the first time he being executed and then the end of the session. So it's the right side of the number. So 14 minus 1. I hope you guys understand. Equals to 30. Okay, so this is the answer for P1. Okay, so let us continue. P2 waiting time 1. Okay, so right here, P2 is the only is being executed one time only. So we will take the 27 minus the arrival time. Okay, so we write down 27 minus 6. Okay, so equals to 21. Okay, so this is the final answer. So let's move on. P3. So it's the same. P3 1 time, 2 time. Okay, so 5. Okay, 5 minus P3. Okay, minus arrival time 4. Okay, 5 minus 4. Okay, plus, because there's one more. There's one more time that P3 being executed. Okay, so okay, as you can see right here, so it's 6 minus how many? Of course, 6. 6 minus 6. So 6 minus 6. Okay, so how many that we got? 1. Exactly. Okay, we continue. We got P4. Okay. The first group, okay, we will take the number from the left side. 1 minus P4 arrival time 5. Okay, guys, I'm sorry because I just did a small mistake. Okay, so this right here is not P5. I'm sorry, it's not P4 the answer. Okay, so it's P5. Okay, I typed wrongly. Okay, so okay, we continue. The waiting time P4 right here is only being executed once. Okay, as you can see right here. So okay, this number on the left side minus the P4 arrival time. So 9 minus 5 okay, equals to 4. Okay, so this is the final answer. So we move on to the next process. It's process number 5. So right here, as you can see, there's four time process number 5 being executed. So there's a simple way actually. So it's just 1 minus 1 equals to 0. So let's move on to the next process. So it's process number 6, and let us see how many times it's been executed. So as you can see, there's only one time process 6 being executed. So okay, process 6. 19 minus 2 equals to 17. Alright, and then the last one, P7. Okay, let's see. So P7, yes, it's also been executed one time only. So 35 minus 3. P7 arrival time is 3 equals to 32. Okay. So right here we are done for the waiting time. But right here we need to calculate the average waiting time. Right now, we will add up all of this waiting time, the process, the final answer. Okay, so 13 plus 21 plus 1 plus 4 plus 0 plus 17 plus 32. Okay. Sorry, there's a typo right here. Okay, so the final answer is 88. Okay, so this is the answer. Okay, I'm sorry. And we need to divide it by how many process is there. So 1, 2, so it's 7 process. So, and we need to divide it by 7. So let's open our calculator one more time. So 88 divided by 7 equals to 12.571. Okay, so we just write down 12.57. So this is the final answer for this, all of this. So okay, so I'm done with this video. So thank you, Miss Lim, and the other student that watched this video, and thank you for your time, and I will talk to you all later.